We're going to solve each of these three equations. Notice that these equations are quadratic equations with complex coefficients. For the first equation, we want to find all complex numbers z, such that z squared is equal to 3/4 plus I. So basically, we're looking for all the square roots of 3/4 plus I. And using the method we discussed in finding nth roots, we can find that the square roots are 1 plus 1/2 I and its negation minus 1 minus 1/2 I. And let's just check that this is indeed one of the square roots. So 1 plus 1/2 I squared is the same as 1 plus 1/2 I times 1 plus 1/2 I. And using the distributive law, we have 1 times 1, which is 1. And then 1 times 1/2 I, that gives us 1/2 I. And 1/2 I times 1, that's another 1/2 I. And then 1/2 I times 1/2 I, that's minus 1/4. And so we have 1 minus 1/4 giving 3/4. And 1/2 I plus 1/2 I is I. So indeed, 1 plus 1/2 I is a square root of 3/4 plus I. And the negative of that is also a square root of 3/4 plus I. Let's now look at the second equation. This equation is almost like this equation. We have something squared equals 3/4 plus I. And so what that means is z minus 1/2 I needs to equal to one of these square roots. And so z minus 1/2 I is 1 plus 1/2 I, or z minus 1/2 I equals minus 1 minus 1/2 I. And if we work this out, z will have equal to 1 plus I, and this will give us z equals minus 1. So these are the solutions to the second equation. What about the third equation? Well, as we have seen, something like this is easy to solve. And so if we can write this equation into this form, then the solutions will become apparent, because if S1 and S2 are square roots of S, then the solutions are S1 minus R and S2 minus R. So the question is, can we always rewrite this equation into this form? And the answer is yes. And the method for doing so is the method of completing the square. So suppose we start off with an equation that looks like this, where P and Q are complex numbers. Now we subtract Q from both sides, we get this. And the method of completing the square tells us that I have to add P over 2 squared to both sides of this equation. And doing so will turn the left hand side into Z plus P over 2 all squared. And the right hand side again is simply P over 2 squared minus Q. And now this equation is in this form. And so we can take the square root of the right hand side. Once we have the square roots, we can solve for Z. So let's look at what happens here. So this will now be our P, and this will be our Q. So equation 3 can be rewritten as Z plus minus 2 plus I divided by 2. And this is all squared equals minus 2 plus I divided by 2 all squared minus Q. So Q is minus 2I, so this is plus 2I. Now we can simplify the right hand side. So minus 2 plus I divided by 2 all squared is 3 minus 4I divided by 4, and that's 3/4 minus I. And so this whole thing here simplifies to 3/4 plus 2I minus I, and that's just plus I. Now we have already worked out the square roots of 3/4 plus I, and they are here. So to obtain the solutions to 3, we can set Z to 1 plus 1/2 I minus minus 2 plus I divided by 2, and that will give us 2. And the other solution will be z equals minus 1 minus 1/2 I minus 2 plus I divided by 2, and that will give us minus I. So the solutions to equation 3 will be z equals 2 and z equals minus I.